15,000 years after the construction of the first space colony, planet Kepler 452b, 1,400 light-years from old Earth. Hello, first-year students. We're glad to welcome you to the Intergalactic University. Endless space is now home for us humans, but thousands of years ago, we used to live on just one planet we now call Old Earth. Yes, I understand it's difficult to believe. Today, it's one huge nature reserve. Mammoths and stegosaurs walk on its surface, and pterodactyls fly in its skies. It turned out to be easier to recreate animals that roamed it millions of years ago than to understand how our ancestors lived. The Great Cataclysm made them abandon the planet in a hurry, leaving much of its legacy behind. And now, we're studying it anew. But our excavations leave more questions than answers. Skyscrapers, highways, shopping centers, coffee shops, everything is buried under sand and soil. Rust has eaten away the metal, and time turns concrete into dust. Even the Hoover Dam and the Three Gorges Dam in China have crumbled. The colossal structures turned into heaps of stones. The remaining buildings have become overgrown with plants and turned into a home for millions of living creatures. But there's good news as well. Faces carved into Mount Rushmore are still visible. The mountain is granite, and this rock is one of the hardest on old Earth. For over 15,000 years, the faces of U.S. presidents have deteriorated by only 2 inches. The monument will stand for millions of years. And the latest expedition to the Sahara Desert managed to dig out the Great Pyramid from the sand. Now any tourist can buy a ticket and look at that wonder, which even Earthlings considered very old. Surprisingly, ruins and crumbling walls of medieval castles in Europe have survived. They're built of massive stones and without metal fittings, which expand and destroy the stone when rusting. Our ancestors left behind a huge amount of garbage. Empty bottles, plastic packaging, wrappers. All this helps scientists to recreate the consumption patterns of people of the past. Thanks to this, we know for sure that in the 2000s, almost 8 billion people ate mostly chips, chocolate bars, and pizza. And they rarely drank ordinary water. They loved coffee, though. 60% of Earthlings lived on the internet for 7 hours a day. 2 billion websites worked 24/7. At first, information was stored on hard disks, flash drives, and compact disks. But this kind of storage went obsolete after a couple of years. The cloud took their place. It was an online storage with servers connected to the global network. They recorded the entire life of Earth's civilization and were stored in data centers. In space, the Earth's internet didn't work well. Apparently, huge distances and lack of technical knowledge did their job. Imagine that a Pluto resident wants to know the difference between margarita and calzone pizzas. They click the link and wait for a couple of hours for it to open. If the dough's already in the oven, no good. Each colony organized its own internet by sending satellites to orbit their planets. It took time to connect thousands of colonies into the intergalactic web we now know as Uninet. When the cataclysm struck, people had to escape, leaving their planet to its fate. Electricity went out, no one maintained the servers and data centers, and lots of info about their civilization was lost. We've scanned miles deep into the Earth and found many interesting artifacts. Students, I invite you to look at this amazing thing. The Earthlings called it a camera. People took pictures of their food, morning runs, and new shoes on it. One thing our scientists couldn't comprehend, though, is that ancient people used to communicate with its help too. One of the main mysteries of the past are the dishes of different sizes. Archaeologists find them in almost every home. They bear these names: Buddy, Cosmo, Rex, Princess. We know these were the things from which dogs and cats ate, but we don't know why people pampered these animals so much. For example, archaeologists recently unearthed a beauty salon for poodles in San Francisco. I also love my dragon from the jungles of Galisa 832C, but I don't perm its fur and manicure its claws. And this is my favorite artifact, a book. There's nothing more valuable in the universe. There's only one sample in my antiques collection. It's a cooking recipes anthology. I paid a fortune for it. The ruins of museums are treasures for archaeologists and all the new humanity. These buildings collapsed a long time ago and now look like ordinary hills, overgrown with trees and grass. Museums are like pearls in the ocean. They lie at the bottom and wait to be fished from their shells. And sometimes, archaeologists manage that. Books, paintings, documents, and clothes have mostly turned to dust. But we can enjoy the statues that were carved out of marble by masters of ancient Greece and Rome. On the walls of caves around the world, there are drawings of animals and handprints of the first people. They didn't know how to read, drive a car, or fly a spaceship, but their paintings have survived. It's incredible. Over thousands of years, time has eaten up huge dams, cities with skyscrapers and bridges, and the palm of an ancient human still adorns the cold and rough wall of a cave. Space archaeology is becoming more and more popular. Thousands of tons of space debris fly around old Earth. The real sensation is the discovery of the Voyager 1 probe. Earthlings sent it into space at the very beginning of their development. I see your condescending smiles. Today, such a device can be assembled by any first-year student from spare parts in their parents' garage. But, dear students, let's not laugh at our ancestors. They tried their best. Voyager isn't a simple satellite. The device can be compared to a message in a bottle thrown into the sea. And the cosmic sea is millions of times larger than the Pacific Ocean of old Earth. Engineers of the past left a time capsule with a message in the probe. It contains photographs of people and the nature of the planet, as well as scientific information about the Earth. 90 minutes of recorded music are of particular interest. This is a real gift from our ancestors to us, to the people of space. Radio signals that humankind sent into space have also survived. We've tracked them. Radio broadcasts, phone conversations, even music charts continue their journey through space. Millions of years later, they'll weaken and leave behind only an electromagnetic echo. In 2020, there were 1.4 billion cars on old Earth. Unbelievable! But they moved along asphalted roads on rubber tires, not in the air. When humans flew into space, they left their vehicles on the planet. Within just a couple hundred years, the cars went completely bust and turned into piles of metal, plastic, and rubber. One that survived for millennia was the Lunar Roving Vehicle. There's no air, no water, and no earthquakes on the moon. Anything that comes here becomes kind of suspended in time, and that's what happened to the rover. Archaeologists have found a lot of other whole and crashed spacecraft on the moon. These devices are priceless artifacts in the Museum of Primitive Earth Technology. In the Svalbard archipelago in the Arctic Ocean, scientists have unearthed the Global Seed Vault. Earthlings built it in 2008. It became a real sensation. The huge silo contained 4.5 million samples of 500 seeds each. Billions of seeds have helped provide agriculture for the colonies. Now you can eat popcorn and hamburgers with real bread rolls thanks to those. For thousands of years, the seeds were kept without human attention. This isn't a miracle, but an accurate scientific calculation. The vault is built underground at a depth of 390 feet. There are no earthquakes or floods there, and the permafrost provided the optimum temperature for the seeds to survive. Most metals are mined from ore. These ores don't contain pure metals, but only their chemical compounds. To get pure iron, the ore must be smelted first. But there's a problem. Metals from ore oxidize on contact with water or oxygen. Simply put, they rust. This is how metal returns to its natural ore state. That's why nails, metal fences, bridges, and houses rust and collapse. But this doesn't happen with gold, silver, and platinum. Things made from these metals are eternal and will never lose their shape. Of course, if you don't start hitting the rings and pennants with a hammer. During excavations, archaeologists find thousands of jewelry items. Earthlings love to wear them on their bodies. Crowns, luxurious necklaces, wedding rings. All this jewelry is now history, kept in galactic museums.
So how alone are we in our galaxy? Crickets. Yep, we're mostly alone out here. But are there other civilizations lurking somewhere out there in the depths of the Milky Way? Could they possibly have evil intentions and be a threat to us? Hey, like we need more threats. Well, hey, let's have some fun with this. Some theorists reviewed humans' history and past actions toward one another. No miscongeniality awards there. And assuming they were somehow like us, used this to calculate the probability of space invaders. They determined that there could be 4 evil civilizations in our galaxy. The 4 could be eager for intergalactic domination, or maybe just for a good game of dominoes. They could be highly advanced in technology, or they've only just invented an evil version of game consoles. To understand how advanced these cultures could be and what to expect, there is a way to define their threat levels. A method called the KARDASHEV scale analyzes intergalactic nations' possible abilities. With 3 different levels, it reviews the amount of energy a civilization could take from their star, indicating their tech level. This only includes those that have reached interstellar communication. So any other beings out there using, let's say, space pigeons will of course be excluded. Type 1 shows that they can harness the energy from the sun, but only from what is received within their own planet, like solar power panels. Type 2 is where they can use the energy directly from the sun, like through a Dyson sphere. It's used to harness all of the sun's energy, having been built entirely around it. And lastly, Type 3, where civilization can use all elements provided by the galaxy, with the power to not only harness the energy from stars, but also black holes, even the central supermassive one. These levels are important to assess how advanced civilizations could be out there. The Milky Way is estimated to be around 13.6 billion years old. Modern humans have only been around for the last 200,000 years, and we're only a Type 1. It's scary to imagine the time other beings have had to develop. We're considered a bit of a late bloomer in comparison. Earth is, shall we say, late to the party because we're located on the outer arms of the galaxy. Mathematicians posit that more centralized star systems have had more time to progress. Now, with that in mind, how common would other intelligent beings be in the galaxy? With all the life-ending events Earth has survived, it's a miracle to have a planet like ours, and that we would be unique. Or are we? Well, there are 100 trillion stars in our galaxy, and there are up to 200 billion planets, with an estimated 300,000 exoplanets capable of sustaining the kind of life we know about. From those habitable planets, how could we tell which ones have other beings eager to send us an email? No one's had the time to individually count, of course. The Drake equation can give us some rough numbers if we take averages of a few key factors. It breaks down the criteria of how many planets with life are intelligent enough to make communication. The numbers are huge, considering how many stars might have planets. And from there, we distill it down further to those within the habitable zone in the solar system. This zone is called the Goldilocks zone, as it's not too far from the sun and not too close to it. It's just right. We reduce the numbers even further by calculating which of those habitable planets will then be able to support life. And from those random places, the equation takes the probability of how many intelligent beings will be and if they are intelligent enough to communicate. The criteria is complicated, and so it's not an easy equation to explain. But from its estimate, there could be up to 100 million planets with intelligent civilizations. But just like with Earth history or struggles, these civilizations may also have their own challenges. World-ending events should be thrown into the equation, like asteroids, solar flares, supervolcanoes, and supernova. They could also destroy themselves through technology, like AI dominance or nanotech, or by affecting their own ecosystems and running out of resources, or by just acting stupidly. If we take these into the equation, the remaining living civilizations could be around 15,000. But what could they possibly want from humans? We do have an abundance of rare earth materials that could be of value, ready to be harvested and easily collected. Besides an appealing vast amount of water they could suck dry, hydrogen is a required element of rocket fuels. Though these things aren't exactly rare in the galaxy and could be harvested easier from other closer solar systems or asteroids. Our technology might be intriguing to them. Our range of innovations on Earth, invented while being isolated in separate countries, help provide different technology paths around the world. Other civilizations could have followed a completely different route and didn't learn the importance of many things we have here on Earth, like karaoke. The same goes for applied sciences, where they may have evolved in different atmospheres with different elements. Their science would be mainly affected by that, and ours would provide them with more knowledge. Then, there's one of the rarest things in the galaxy, that Earth can support life. This would be very useful for an intergalactic traveler, rather than going through the long process of terraforming an unlivable planet. Why not just take it? With a cozy outpost, it would be a lovely little holiday destination when they need some time off from conquering other civilizations. Fortunately, they wouldn't be interested in eating us, or probably wouldn't have an appetite for anything on Earth. They would need to have similar biochemistry and require the same enzymes to process the molecules we're built from. Whew! But the most likely thing they would want is to remove any competition. The biggest threat to them is anything that would provide a challenge to their domination. But before you get too frightened by these evil civilizations, this was based on human behavior. It's possible that any beings out there could lack or avoid many of our human emotions. For instance, their capacity for anger might be limited, or they could have evolved without it. They could come from a world with a history so different from ours that they could be overly trusting, making us the bad guys. But again, they may also lack empathy and other positive traits we have. Well, let's hope they only have our nice traits. Luckily, there's a big thing that separates us from everything else. The galaxy is huge, and it takes a very long time to go anywhere, even to our closest solar systems. The fastest thing we've sent into space is the Galileo probe, which travels up to 100,000 miles per hour. Even so, it would take 72,000 years to reach the closest star system, Alpha Centauri. Still, with a newly proposed laser-guided probe that could travel at 1/5 the speed of light, it would yet take up to 20 years to make that journey. On a larger scale, the Milky Way is over 105,700 light-years across. If a civilization was even capable of light speed, it would take them hundreds of thousands of years to travel from one end to the other. With a huge distance between the small number of civilizations, the only successful contact would be through advanced interstellar travel. But to achieve such a long journey, the greater the mass to be accelerated, the more energy is required, so it's not likely anything too large will be sent. But they could travel here very quickly in a small shuttle, using the ability to break cosmic speed laws. They may already be here, watching us closely, or just binge-watching Netflix. They would need very advanced technology, and the number of species obtaining this is theorized to be only 2 out of the 15,000. That means there's a 1/100% chance of evil civilizations capable of visiting us soon. If they do know we're here, and they want something from us, it's likely to take them thousands, if not millions of years to arrive. So, we've got plenty of time to relax. Time for more bright side.
Did you know that humans are real space people? You were born in space. Heck, even I was born in space. We were all born in space. But for humans to be here on Earth, so many conditions have to be precisely correct that it's highly improbable that we even exist. But we do. First, we, and any other space creatures who might be out there, have to live on a planet orbiting a yellowish white star, not a red star or a blue star. not a blue star, because they burn out too quickly. In a few million years, there wouldn't be time for evolution to do its relatively slow magic and produce intelligent beings. Blue stars also tend to swell up and turn red when they collapse and explode. It makes it highly unlikely that any civilization could prosper near a blue star. Red stars, which are by far the most numerous kind of stars, don't seem like good prospects for intelligent civilizations to orbit around either. Red stars are so cold and so dim that a planet that could grow a civilization must orbit very closely to the red star, which would expose the planet to intense, deadly X-ray radiation. So, though red stars are the most numerous and appear to have many planets orbiting them, red stars are a no-go for hosting intelligent, civilized life like our own. That leaves the yellowish stars, about 10% of all stars. However, an important fact must be met before considering the possibility of intelligent life living around a yellowish star. That fact is that the yellow star must be a third-generation star. Only third-generation stars will contain sufficient chemical diversity to sustain advanced life forms. Each time a star explodes, heavier, more complicated elements are created. The explosion expelled these elements and eventually found their way into a nebula. Gravity within the nebula will gradually form the next generation of stars, and so on. Our bodies need calcium for our skeletons and teeth. Our brains need zinc to help create the electrochemical signals that make us move, feel, and think. Our blood needs iron. Therefore, our bodies need to have formed around a third-generation star, and a yellow one. Amazingly, Earth has all the different elements in the universe, all 94 naturally occurring ones, from hydrogen to plutonium. Maybe that's why we're here. And we have to thank our third-generation yellow dwarf sun for that. Why yellow? Because yellow stars burn very steadily by nuclear fusion without significantly changing brightness over billions of years. If our sun became just 6% brighter or dimmer, Earth would become too hot or too cold to sustain civilized life. Fortunately, Earth is in the habitable zone around the sun. The habitable zone is where liquid water can exist on a planet. But that brings us to the second condition necessary for intelligent life to live in space: the planet itself. Recent studies with the Kepler telescope have shown that 1/4 of all yellow dwarf stars may contain Earth-like planets in the habitable zone around yellow dwarf stars. That figure is somewhat debatable. It might be as few as 1 out of every 33 yellow dwarf stars, but that's still a lot of planets orbiting yellow stars in habitable zones. So let's consider the second essential component for intelligent life in space: the planet itself. The planet that would bear intelligent civilization must have many particular characteristics that aren't easy to come by individually, and even more rare to find in combination. Most importantly, the planet must have protection against the star it's orbiting. Because stars shine by nuclear fusion in their cores, gas in the outer shell of the sun, called the corona, gets blown off into space in what's called the solar wind. Our United States satellites take constant readings of the force of the solar wind, which is mainly electrified, ionized, hydrogen nuclei, along with a smattering of atomic nuclei from the many other elements found in the sun. It's not the atmosphere that protects Earth, it's the magnetosphere that stops or deflects the dangerous solar wind, causing aurorae when the solar wind is attracted to Earth's magnetic poles and electrifies the air of the upper atmosphere like a fluorescent bulb. Without a magnetosphere surrounding it, any planet, even those in habitable zones, would be toasted by a constant rain of ionized hydrogen nuclei from its star. A planet with life on it must have a magnetosphere strong enough to deflect the solar wind. Not every planet in our solar system has a magnetosphere. The gas giant planets, Jupiter, Saturn, Uranus, and Neptune, have magnetospheres, but gas planets cannot have civilizations. Of the solid worlds, only Earth and Mercury have magnetospheres, and Mercury is too weak to stop the solar wind because of its closeness to the Sun. Another protective shield that keeps the Earth safe from the Sun is its atmosphere. The atmosphere is about 300 miles thick, with most of it concentrated within just 10 miles of the Earth's surface. The atmosphere protects life on Earth from both the Sun's ultraviolet, UV, radiation and X-rays. The gas, ozone, which is 3 oxygen atoms bound into a large gas molecule in the upper atmosphere, blocks most of the sun's UV radiation from reaching the ground. The planet Mars, whose atmosphere is 1,000 times thinner than the Earth's, has no ozone, and the sun's ultraviolet emissions have totally irradiated its surface. A planet must be able to stop the UV radiation from its star, so the specific composition of the atmosphere is critical for any planet to have an intelligent civilization. We've got it, but it is a rare and precarious mix. The planet must have some part of its surface solid to walk and work on. The planet must have a crust. It's pure science fiction to consider underwater civilizations or floating civilizations in the atmospheres of other planets. A planet's crust must have tectonic plates that move. This movement of tectonic plates creates the subduction of the crust. Subduction is when one tectonic plate slides under or over another, bringing the fresh matter to the surface. This renewal of the chemical properties of the planet prevents chemical equilibrium, where nothing is reactive. Earthquakes and volcanoes also contribute to the process of geochemical renewal. That's right, earthquakes and volcanoes are good. Subduction of tectonic plates, then, is another planetary essential for life. Mars doesn't have tectonic plate activity. Neither does Venus nor Mercury. Mercury is one big tectonic plate, but there's no ongoing plate activity other than slight shrinkage. One big reason these planets have no life is that there's no geochemical reactivity because there's no tectonic subduction. And that brings us to the Moon. Yes, the Moon. To say that the Moon keeps us alive may seem like a stretch, but the contribution of the Moon to life on Earth is essential. First, the gravity of the Moon as it moves through space with the Earth not only makes the ocean tides ebb and flow, it also helps the rotation of the Earth to churn or stir the magma inside the Earth. The motion of the magma inside the Earth, with its high metallic content, contributes to the creation of the Earth's magnetosphere. So, the Moon keeps us safe in space by helping Earth become a geodynamo and creating our magnetism. The Moon is the largest moon in the solar system compared to the size of the planet it orbits. Essentially, it's primary. Many people consider the Earth-Moon system to be a double planet, but that's another issue. Another thing the Moon does that keeps life safe on Earth is to hold the Earth steady. Because the Moon is gravitationally locked to the Earth, the Moon acts much like a balance pole does for a tightrope walker. Therefore, the Earth doesn't wobble very much compared to other planets. This wobble is called libration. If the Earth wobbled as much as Mars or Saturn, not only would our weather become chaotic, but farming might have been impossible. These rare or unique astronomical circumstances work together to make Earth habitable for humanity. Many other factors are not astronomical, such as evolutionary, biological, and chemical factors required for life to exist on Earth. The probabilities, or improbabilities, are multiplying. Taken all together, we are very, very lucky to be here. In fact, we're so lucky that we may have hit the jackpot. Considering all the possibilities, it's doubtful that anywhere else in the universe is as fortunate as Earth.